Okay, so welcome to the video presentation of our Module 2 review. This first slide is basically all of Module 1, and I'm going to add maybe a few more tricks to make it even easier at this point, but you should be able to do this pretty good. And those of you that struggled on Module 1, if you have this mastered and you perform well on these type of problems on the test, I might be able to help out your Module 1 score. So do your very best. Make sure you understand all of this. So number 1, create a table of values with at least 4 points. Now, you could use any 4 points you want in this table that are represented by this equation right here. But let's keep it as simple as possible. That equation, well, that's slope-intercept form of a line, right? Which is just y equals mx plus b. Y equals m times x plus b. All right? So you know your slope and your y-intercept right here. Let's write that down below. Okay? I'm going to start with a 0 here too to keep this as simple as possible. And I know I'm going to want to start with a 0 because I have slope-intercept and I can see my y-intercept. And then I could go 1, 2, 3. Keep it simple. Now, what is the slope? Well, m is 4. The slope is 4, and that's the same thing in a sequence as a common difference. So slope always equals a common difference, and that's going to be 4. Okay? And then what's b? Well, b is my y-intercept. That's 2. So I'm going to write that as an ordered pair right here. When x equals 0, my y has to be a 2. So I'm going to start with a y equals 2 right here. Now, you could just plug these x values into this equation and get your outputs. But if you understand that the pattern of change is plus 4, all you have to do is add 4 each time here. 2 plus 4, 6. 6 plus 4, 10. And 10 plus 4 is 14. Now, if you're more analytical and want to plug the x value in, let's take that x equals 2. Well, 4 times 2 is 8 plus 2 more, y is 10. And there's your 10 right there. Now, identify the type of sequence. Well, if I have a common difference, then I must be arithmetic. Identify the common difference or ratio. Well, this has a common difference of 4. We said that already. The type of growth. Well, if I have a common difference, my pattern of change is I'm adding 4 here. That's going to be linear. The recursive form, just like we do every day. F of blank equals blank. Let's look at our very first point right here. The ordered pair when x equals 0, y equals 2. So in function notation, that is f of 0 equals 2. And then f of x equals f of x minus 1. And then what's my pattern of change? What am I doing to the previous term every time? Well, look at those y's. We're adding 4. The common difference of 4. And then the y-intercept as an ordered pair. Well, we already wrote that up there. 0, 2. There it is, 0, 2. Okay, now let's do the exponential function over here on the right. Y equals 2 times 4 to the x power. That's exponential. Y equals a times b to the x. Y equals a times b to the x. Now again, to the x, my first x is going to be a 0 again. And let's keep it simple. How about we go 1, 2, and 3. And now, what do we know here? Well, let's see. The a is always my first y value. All right, it's my first output. All right, so when x equals 0, y has to equal 2. All right, and then the b is my base. That's what I'm multiplying by every time. So there's my 2 right there. And then my b is a base that's also a common ratio. And my common ratio would be in this problem a 4. So that means I'm just going to take my outputs and multiply by 4 every time. 2 times 4 is 8. Times 4 is 32. Times 4 is 128. And you could plug any of these x values right into this equation and get it that way too. Like if x is 2, well 4 to the second power would be 16, and 16 times 2 is 32. Look at that y right there, 32. So use the method that works for you. Now, identify the type of sequence. Well, if I have a common ratio, that means I am geometric. Identify the common difference or the common ratio, and we've already said that the common ratio is that 4 right there. The type of growth. Well, if I'm geometric with a common ratio, then my growth would have to be exponential. And what's my recursive formula? Here we go. Let's fill in the blanks. Look at your table. F of 0 is 2. F of 0 is 2. And then f of x equals f of x minus 1. And then what's my pattern of change? What did I do to the previous term every time? I multiplied by 4 times 4. And then my y-intercept, well, let's give it right here at the table. And we already talked about that, 0, 2. So that's a review of all of Module 1 right there. Get really good at that, okay? And if you want to complete the tables, I would suggest analytically, I would suggest always going, keep it simple, 0, 1, 2, and 3, all right? And then just plug your x values into the expression and find your y. Do it that way, okay? All right, number 7. Mr. Gibbons has 150 tests that need to be graded. Every minute he is able to grade 2 exams. The relationship between minutes and exams left to grade is, all right, so this is just a context problem. Is this situation discrete or continuous? Well, my pattern of change is every minute I am grading 2 exams. So the number of exams that I have graded would always be a whole number. 2 exams, then 4 exams, then 6 exams, then 8 exams. So I would call this discrete. Number 8, Mr. Gibbons walks his dog every morning at a rate of 4 miles per hour. So the relationship between hours and miles walked is, all right, well, think about this. Every hour, my dogs and I are walking 4 more miles. We're adding 4. The pattern of change is 4 plus 4. All right, so that's linear. All right, and let's just add a little bit to this. So I'm starting at home before I start my walk, so I'm going to go slope intercept, mx plus b. Now every hour I am walking 4 miles, so my slope would be a 4. And I start at home plus 0. There it is, y equals 4x. That's linear. Right there. Now, in June, the temperature of the water in a pool increased by 4% every week. Now, think about that. The relationship between weeks and the temperature in the pool. Okay? Well, again, this is discrete or continuous. Now, as the summer goes on, my outdoor pool warms very slowly and continuously. That's going to be continuous. And let's even add an equation to this. It's continuous. And the equation, and that will lead to this answer down here, right? Well, again, I'm increasing a temperature by 4%. So I don't know what my pool is going to start at. So I'm just going to call that an A right there. Now, if my pool is increasing in temperature by 4% every week, then my common ratio would be 1.04 right there to the x. And of course, that is exponential. So number 9 would be a continuous exponential function. A times 1.04 to the x power. Okay, for question number 10 through 13, use the discrete relationship shown below between the number of fishermen on the dock and the number of trout caught. So my input would be number of fishermen, 1, 2, 3, 4. And my output, the number of trout caught, 5, 10, 15, 20. Looks like everybody is getting their limit. It must be opening day. All right, number 10. The relationship between the number of fishermen and the number of trout caught is. So look at the number of trout caught, the output. What's the pattern of change? Does it look to you like we're adding 5 every time? Well, 5 plus 5 is 10. 10 plus 5 is 15. And 15 plus 5 is 20. Yeah, we have a common difference of 5. So if we have a common difference, our pattern of change, we're adding 5 every time, we must be linear. What is the domain of the function? Oh man, and they have these sets of numbers. Now this was in your ready, set, go. If you guys have been doing your ready, set, go carefully, you might see the answer right now. If not, I would write the domain the way we usually do. And for this is a discrete relationship, this is discrete. So the domain would just be my set of inputs. So X is the set, and just list your X values, 1, 2, 3, and 4. And so on. Okay, so that's how we would write this domain right here. Now, is that all real numbers? No, all real numbers are any number, decimals, fractions, and positive whole numbers like we see right there. Okay? B, positive real numbers, also continuous. It's just all the real numbers to the right of 0. Fractions, decimals, and whole numbers just like we see right there. Now C, all whole numbers. You guys need to know that the set of whole numbers does not begin with a 1, it begins with a 0. So if the first input in my table was 0, like if I had the point 0, 0 on this table, it would be all whole numbers 0, 1, 2, 3, 4, and so on. But my first X is a 1, so this is going to be the positive whole numbers, D. Now, which of the following functions describes the relationship? Well, these are all recursive formulas right here, right? And my first point is f of 1 is 5. Oh, those are all f of 1 is 5 right there. All right, so now I got to go over here and look at my pattern of change. Did we multiply by 5? Did we add 2? Did we multiply by 2? Or did we add 5? Well, we said the common difference was 5. We're adding 5 every time. So it's f of x equals f of x minus 1 plus 5. So the answer to 12 is D. Now, let's graph. And you guys are an expert at graphing. But let's get all our points, graph and label. So what does the x-axis represent? The number of fishermen. Let's write that out, number of fishermen. And what does the y-axis represent? The number of trout caught. That's how I label that. Now, you don't have to, but I'm going to rescale my x-axis. I'm going to go 1 like that. And I'm not going to list them all. That just assumes this would be 2, this would be 3, and 4. And now, I've got to get up to 20 trout caught, so I can't go by 1s here, so I better go by 2s here. And I'm not going to label them all, just know that here, every hash mark is 1/2, and on the y-axis, every hash mark is 2. Now let's plot our points. X equals 1, y equals 5. 1, and then I'm going to go up to 2, 4, 5, right there. Whoa, that's a big old dot. Let's go to 2, and then we're going to go up to 10. 6, 8, 10, right there. Okay, now let's go over to 3, and we're going to go up to 15. There's 10, 12, 14, 15, right there. All right, and then let's go over to, what was that x value? 4, and we're going to go all the way up to 20. So 4, and there's 15, 16, 18, 20 right there. and there's the scatter plot. And I'm not going to draw a line through those because this is a discrete situation. If I did draw a line, it'd have to be a dash line, but I'm not even going to do that. And there we go. That's a cool slide. All right, number 14. They give you a table. The table of values below represents the function f of x. So we have inputs x, 0, 1, 2, and 3, and outputs f of x, 2, 5, 8, and 11. Create a graph of the function. Okay, well, let's make sure we label our graph. So let's call the horizontal axis x and the vertical axis f of x. Okay, now do we need to rescale? We're just going 0, 1, 2, and 3. So how about I go every other one here? Let's see, I'm going to call that a 1 probably. Yeah, and if I don't label anymore, that just tells me that each hash mark here is worth 1/2. And you could go ahead and label them all if it helps you to graph. I'm not gonna here. All right. Now my outputs 2, 5, 8, and 11. So let's see. I think I can just call those 1s right there. And if I'm gonna do that, I'll leave them alone. Okay. So let's see if we can plot points. When x equals 0. F of 0 is 2, right there. Big dot again. And at 1, I have an output of 5, 3, 4, 5. At 2, I'm going to have an output of 8, so there's 5, 6, 7, 8. At 3, I'm going to have an output of 11, so there's 8, 9, 10, 11. And there we go. Now, and again, I could keep going, but I'm just going to use what I have in the table. And now, discrete or continuous. All they gave me is a table, so I'm not sure if this is discrete or continuous. So, you know, you guys could do a solid line, a dash line, or no line at all here and still get full credit. Okay, now, write the explicit form of f of x. So let's write an equation that represents this table. Well, you got to think, what's the pattern of change? We're adding 3 every time. This is linear, all right? And I have a y-intercept. When x equals 0, y is 2. So I would use slope-intercept. Common difference, what's the common difference there? I'm adding 3 every time. That's going to be my slope. And my first x is a 0, so I get to use slope-intercept form of a line. Y equals m times x plus b. So y equals, and slope and common difference are the same thing, so I'm going to have a slope of 3. All right, and look at this. If I go from this point to this point, I'm rising 1, 2, 3, and I'm running 1/2 1. That's the slope of 3. And then plus b, my y-intercept. Well, when x is 0, f of 0 is 2, so my b is a 2. And there it is. Number 15. The graph shown to the right represents the function g of x. So this time they're giving me the graph of a continuous function right here. All right. Now, create a table. Now, the graph starts with a -1, you guys. But to make it easier on us, let's just begin with the 0 right here. All right, so that point right there, x is 0. And then I can continue my x's like 1, 2, 3, or I can go to my g of x's now. Let's go ahead and continue the x's 1, 2, and 3. All right, now, what is my first output? 1 when x is 0, g of 0 is 1, 2. Now, let's go to x equals 1 and look at that output. That'd be 1, 2, 3, 4. And then when I go to x equals 2, I'm going to go up to 4, 5, 6, 7, 8. And then when x equals 3, I'm going to go up to 8 and then go what? 9, 10, 11, 12, 13, 14, 15, all the way up there to 16. Look at that. All right, let's go ahead and put those y values in here. So when x equals 1, I went up to 1, 2, 3, 4. When x equals 2, I went up to, well, there's 4 right there, 5, 6, 7, 8. And when x equals 3, I went all the way up there, and I already counted those once. So let's do it one more time from here. That's 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so write the explicit form of g of x. Well, let's look at the pattern of change there. We're not adding, we're multiplying. It's exponential then, and we began with an x equals 0 to make this as simple as possible. So now we can write this as y equals a times b to the x power. If we would have started with this -1, we would have had to use our other form of an exponential, but we're keeping this as simple as possible. So we're going to go y equals, and a is my first output, that's a 2, and then b is what am I multiplying by every time? What's my pattern of change? Well, we have a common ratio there, and we're multiplying by what number? 2. So that's the base of my exponential. Beautiful. Number 16. Jacob has 800 hours documented in his logbook. To get his commercial license, which he has already done by the way, he will need to get 6 more hours documented every week for the remainder of the term. Write the explicit and recursive functions that represent Jacob's situation. So recursive, that's easy. Okay, well, Jacob right now has 800 hours. So I'd start off with f of 0 equals 800. F of 0 equals 800. And now what's the pattern of change? Well, what does he need? He needs 6 more hours documented every week. So every week we're going to add 6. That would be f of x equals f of x minus 1 plus 6. There's your recursive right there. Now your explicit. Well, my pattern of change is adding 6, so that's going to be slope-intercept, and I'm going to have a slope of 6 and a y-intercept of 800. So I'm going y equals mx plus b. Or y equals, well, I added 6 every time. That's a slope of 6. So y equals 6 times the number of weeks x plus, and how many did he have in his logbook already? 800. And there it is. I think that's the entire review, you guys. Let me double check. Yep, that's it. So that's the review. All right, and email me if you have some questions. Go over this, make sure you understand everything, and you guys have a great day. Thank you.